Hello, everyone, and thank you for joining our session, Data Center Technologies for Scalable and Sustainable Design. This is the second webinar in our Data Center Sustainability series. My name is Rachel Emanuel, and I am today's moderator. Before we begin, let me highlight some features of this webinar platform. There is a Q&A panel to the right of the slides. During the presentation, you can submit any questions at any time by entering them here. Our speakers will address as many as possible at the end of the presentation. You will receive an email later this week with a recording of this presentation and a copy of the presentation material. This 5-part series covers sustainability trends and innovative technologies that support reliable data center operations while consciously managing environmental impact. Upcoming sessions will run in 2-week intervals through the middle of June. You can find the registration link to sign up for the remaining webinars in the reminder email you received for this session. Your speakers today are Christiane Mueller, Head of Product Marketing for Medium Voltage Gas-Insulated Switchgear, and Diana Garcia, the Mid and High Power Uninterruptible Power Supply Product Manager. Now I'll start by turning it over to Christiane.
Hello together. Diana and myself are going to tell you something today about data center sustainability and how our products fit into these strategies. So we're going to talk about the advantages of using gas-insulated switchgear technology, how digital switchgear concepts work, and why we should use eco-friendly isolating gases. Furthermore, we're going to talk about industry-leading efficient UPS systems, the ABB response for sustainable and scalable modular UPS, the concept of the modular UPS, modularity to accommodate evolving energy demand, as well as ABB modular UPS best-in-class efficiency and dynamic energy response. So the question is, today in 2020, where everybody is talking about climate change and Fridays for Future, what does sustainability mean to data centers? It means that we look at the wider picture from cradle to grave, that we start with responsible sourcing of materials, responsible sourcing of energy, goes over the efficient consumption, and ends at the life cycle end where we want to recycle the materials used and to asset performance to extend the lifetime of the used components in the system. So with GIS and UPS, we are on the one hand looking on the utility side. So medium voltage switchgears are basically used on both sides of a transformer and in various locations in the medium voltage network. And in the second part of the session, we are going to talk about the UPS on the switchboards. So during the session, I'm going to use a couple of abbreviations which I would like to explain. GIS stands for gas-insulated switchgear, and AIS stands for air-insulated switchgears. I'm now going to talk about the drivers of our customers to use gas-insulated switchgear. The main drivers are increased safety, increased reliability, reduced lifecycle cost, and environmental sustainability. Now we're going to look at each one of those a little closer. How can GIS technology improve the safety of your operating personnel? Because we all want our operators to go home to their families in the evening safely and healthy. Well, first of all, because on the right side you can see a GIS feeder panel, where you see 3 gas compartments. You see the 2 gas-filled busbar compartments on top, and in the middle, the gas-filled circuit breaker compartment. The high voltage parts, so the busbars, the 3-position disconnectors, and the circuit breakers are all located inside those gas compartments. So they are protected from environmental influence, which means the fault rate is drastically reduced. Furthermore, most faults happen during the operator working on the switchgear and not during normal operation. So for example, for maintenance or for repair reasons. In GIS technology, we use fixed mounted circuit breakers and integral grounding devices instead of withdrawable circuit breakers like in AIS. Which means that on the one hand, we prevent the operator from accessing any of the high voltage parts, and on the other hand, no mistakes can happen while racking in and racking out a breaker. In addition, most of the common designs on the market are arc resistant, which means they are internal arc type tested either according to the IEC or the ANSI standard. Some of the designs also offer optional pressure relief ducts that would vent away any hot gases and toxic byproducts in the very unlikely event of an internal arc. For the same reasons just explained, that also means that the switchgear works much more reliable because you have sealed gas compartments and the performance is independent of environmental influence. Also, the aging is independent because they are all protected inside the gas compartment. So the probability for a failure is reduced, referring to a study from the IEEE committee from 2002. Roughly 50% of the causes for failure that apply to AIS do not apply to GIS. In addition, it's a low maintenance switchgear, so all high voltage parts inside the gas compartments are practically maintenance free. This also accounts to reduced life cycle costs, because we have lower operating costs due to the reduced frequency, time, and cost for maintenance, for the reduced cost for downtime due to failures, as well as because we have less failures, we need less spares on stock. In addition, when we use SF6 for isolation, the gas has a very unique property. It insulates 3 times better than air, which means that we can move the 3 phases closer together, resulting in a very compact switchgear design. This is proportional to the rated voltage. So at 36 or 38 kV, you can have up to 70% footprint savings when using GIS. This also results in a much smaller substation layout. So while the investment cost for the switchgear itself may be a little higher, it usually pays off when you look at the life cycle cost and also take the substation or container layout into consideration. Globally, we see 2 trends in medium voltage switchgear. One is a trend towards digital solutions, which we're going to talk about now, and the other one is for eco-friendly solutions. So why should you buy a digital switchgear? A digital switchgear can be delivered faster. The faster delivery time is due to the time-consuming CT data clarification is deleted from the ordering process. Because one sensor size fits all. What we do in digital switchgear is we use sensors with a linear curve which do not go into saturation, so basically Rogowski coils instead of conventional current and voltage transformers, in combination with a modern relay with IC 61850 communication and maybe some optional monitoring and diagnostic features. So in addition, the need for configuration in hardware wiring is minimized, and changes can be applied later just in the software logic. There is This also results in reduced time spent on installation and commissioning activities on site due to less interpanel wiring and fewer components to be tested in the low voltage compartment. That means while speeding up the delivery of the switchgear and the installation and commissioning process, you can also generate profit earlier with your data center. Furthermore, sensors are very flexible. Digital switchgear can adapt to the requirements in the network when they change over time. For example, the feeder current. So you could use a 2000 amp feeder also for 600 or 1250 amps and just adjust the software in your relay rather than exchanging the CTs and still measure it correctly. Furthermore, changes during the project execution can be applied later in the manufacturing process than it is the case with conventional switchgear. And IC 61850 is a future-proof standard which ensures efficient future updates as well. The third reason is reliability. Digital switchgear is based on well-known established switchgear hardware platforms and uses sensors. With these sensors, less human interaction is required, which leads to decreased risk of malfunction. They are smaller and reduce the risk of isolation degradation in the switchgear compared to conventional transformers. Furthermore, they are immune against grid disturbances, especially the voltage transformers and ferroresonance phenomena. Last but not least, a digital switchgear brings increased safety because you cannot incorrectly install a sensor as you can do with voltage transformers and then it blows up during commissioning. Also, less material is exposed to high voltage electrical stress, decreasing the risk of failure of the equipment. So having a closer look on digital switchgear, we usually use outer cone feeders, as you can see on the right side, and so these sensors for current measurements will be located on the outer cones of the panels. If you would like to have revenue metering, you can combine for this particular feeder a sensor for protection and a conventional current transformer for revenue metering, because the sensor accuracy is maximum 0.5. If you require 0.2, you would add a conventional transformer. These sensors for voltage measurement can be both mounted on the bus bar as seen on top on the right-hand ZX2 panel or at the bottom on the cable side. The relays would be mounted inside the LVC, and then they can be combined with monitoring diagnostic features such as temperature or ambient sensors. So this concept can be applied to different types of switchgears. On the left-hand side, we see as example a ZX0.2 from ABB, which is used in light industrial applications, and especially applications where a very compact design is required. On the right-hand side, the ZX2 is our bread and butter product for utility and heavy industrial applications. Lately, we have also sold one switchgear that combined both the features of digital switchgear and Air+. So when we talk about GIS, we also have to talk about the isolating gas. Usually, you use SF6, so sulfur hexafluoride, which has a couple of unique characteristics. You can't see it, you can't smell it, it's non-toxic, it's non-flammable, and it's a chemically inert gas, so it doesn't react with any of the materials inside the gas compartment. It's 5 times heavier than air, but it also has a 3 times better dielectric strength than air, and that's the reason why GIS is so compact. Unfortunately, SF6 is a relevant greenhouse gas. So in case it gets released into the atmosphere, it has a global warming potential of 23,000 tons CO2 equivalent and an atmospheric lifetime of 3,200 years. Practically, it should be a closed life cycle, so the switchgear is filled in our factory and delivered to site. There is no gas works required during installation. And at the end of the lifetime, the service could evacuate the switchgear and recycle the gas. However, in some regions, especially in Europe, politicians discuss about a ban on SF6. The answer to this could be the use of Air+. Air+ is a gas that has been developed together with 3M, which consists of C5 fluoroketones. It's a mixture we use in the switchgear that consists of roughly 80% dry air and 20% C5 fluoroketones. And C5 itself has an even higher dielectric strength than SF6, as you can see on the right side. In the mixture we use it has a comparable electrical behavior. But, and this is the major difference, the global warming potential of Air+ is only 1 ton of CO2 equivalent. So it's comparable with air. That's why we call it Air+. It's very robust inside the switchgear, but once exposed to strong UV radiation in the higher atmosphere, it will decompose, so it only has a lifetime of 16 days. Generally, Air+ is offered in different switchgear designs for secondary as well as for primary distribution solution. And as of now, it's not a full replacement, but a very good alternative to SF6. We also have reference projects delivered to Germany and Switzerland already, and they work very well. Currently, this is the only solution that's available for ratings up to 36 kV, 2000 amp, and 31.5 kA. At the lower levels, up to 12 kV, we can also see a trend towards dry air. So that's the end of my part. Thanks for your attention, and I'm handing over to Diana.
Thank you, Christine, for this interesting eco-friendly medium voltage switchgear. So I welcome everyone to the UPS session. To start the session, I would like to introduce some of the data center drivers committed by large data center leaders like Microsoft, Facebook, Apple inside their sustainability strategies, and explain how ABB modular UPS technology is responding to them. It is reported that data center industry is currently responsible for the 2% of all worldwide emissions, a figure which is keeping on rising, impacting on the environment. Therefore, data center leaders have been developing a strong environmental sustainability strategies focused on reduction of operation impact by reducing the carbon emissions and the footprint for the data centers. Of course, when we talk about that, we talk about the modular design and how to replicate these megapads. Reduction of the energy consumptions by using the latest generation of technologies that enable high efficiency and allow effective monitoring and management of this energy. Dynamic energy response, increasing the energy utilizations or scaling back capacity when the expected demand fails. And the environmental sustainability by minimizing the material that we use inside the data center, reusing of the components during the data center lifespan, and of course the recycling that we can apply. How we are responding to these drivers. And basically, the UPS play a vital role inside the data center infrastructure, providing power, reliable power for these large infrastructures. ABB is actively responding to these environmental strategies by providing the most reliable, compact, resilient, and efficient power protection technology. We understand our uninterruptible power supply and energy storage solution play a vital role ensuring business continuity and zero downtime. As a market leader in the UPS technology, ABB is pioneer introducing advanced concepts in modern UPS designs. First, ABB Modular UPS has a decentralized parallel architecture named DPA. With this architecture, each UPS module is equipped with its own rectifier, inverter, battery charger, static bypass, and control logic for autonomous operation. This patented architecture maximizes power availability due to the redundancy for critical components, avoiding single point of failure inside the system. This is the reason why we can bring continuous uptime and resiliency with the DPA technology. To satisfy the mid to large data center customers' demands, ABB has developed three product families based on the DPA platform. To start on the left side, the DPA 250S4 is addressed to mid-sized data center with single power capacity of 300 kilowatts based on power modules of 50 kilowatts. The product was launched in 2018, introducing the best-in-class power efficiency of 97.4%. For mid and high power infrastructures, we present the DPA 500 UPS, which offers in a single system up to 500 kilowatts and is based on power module of 100 kilowatts. For large enterprises and collocations, the new MegaFlex DPA with rated power of 1 mega to 1.5 megawatt based on power modules of 250 kilowatts. The new UPS is launched in March this year at Data Center World London, presenting and validating the best-in-class efficiency with the smallest footprint. Well, large collocations, hybrid data center need to respond very quickly and simple to the power demand without impacting their operations. Modular, scalable, and flexible solutions are a must. Therefore, ABB Modular UPS support the concept pay as you grow by scaling the power capacity horizontally and vertically. For example, the latest UPS MegaFlex DPA is consisting of power modules with power distribution frames. A power frame can house up to 3 power modules of 250 kilowatts for a total of 750 kilowatts, and 4 power modules, and then there is a power frame with 4 power modules for a total of 1 megawatt. The power frames connected to the power distribution frames can be combined to have UPS solutions from 750 kilowatt to 1.5 mega. When operating several cloud infrastructures, standardized power solutions minimize material, inventory, and improve supply chain and logistics. One of our targets is optimize and support the data center footprint. Therefore, high power density solution is an important value, not only for the data center customers, for us as well. Looking for solutions to optimize these precious spaces without compromise the power capacity and the performance. The DPA architecture and the smart UPS design offer a very compact footprint for the large infrastructures, allowing using more effective the space. The system can be connected from the top or bottom, installed against the wall or side to side, offering different installations layouts. In the example that we are showing, there is a solution of 1.5 megawatt UPS, which can be implemented by paralleling 3 DPA UPS for a footprint of 4.45 square meter, or with a single Megaflex DPA with a footprint of 3 square millimeter. When we take basically the latest UPSs, we are able to provide up to 35 space saving for the installations. Delivering smart and high efficiency power distribution is as well one of our values targets. We invest in driving sustainable power technology across the energy supply chain. Therefore, ABB modular UPS are market-leading efficient UPS by delivering the 97.4% efficiency in Doppel conversion mode. Thanks to the 3-level interleaf technology, ABB modular UPS reduce up to 40% energy consumptions over the product lifespan, representing more than 400 tons of CO emissions reductions. But how we achieve so highest efficiencies inside the system? And this is because we optimize the power consumption of the UPS, and then we are able to reduce and minimize the energy waste according to the operating mode. Our target is providing continuous uptime with the best efficiency, with a body of load considering on-site conditions. Therefore, we have implemented in our UPS the different operating mode as BF5 or Doppel conversion mode. In this case, the IT load is granted with the best power quality. But if you have on-site a reliable grid supply, the machine can run on eco mode, having up to 99 efficiency. And in the other case, when the power sources are not available, the system is able to run in battery mode together with the energy storage solutions. And if the load conditions are going low, then the extra BF5 mode can be activated to deliver a leveraged efficiency for the machine. But this is the question is here how we maximize the efficiency at low conditions. And this is given because of the extra BF5 operating mode, which basically optimize the efficiency for low power demands. In case cloud providers have the ability to balance the capacity amongst the locations due to the different time zones, then the load is reduced less than 30%, and the UPS system decides which UPSs go into a standby mode, reducing the energy consumptions and sharing the load with the remaining power modules. In this case, the efficiency of the system is improved. But how much is this impact? Let us review in the following example. On the left side, we have a power distribution topology tier 3 for 1.25 megawatt load with N+1 redundancy. On the right side, we have an example with two UPSs working on power load condition of 50%, but with an efficiency of 97.4%, and the legacy UPS with 96%. Over a year, this efficiency of 1.4% represent up to 45 energy savings. This is in the case when the IT load is constantly low at 50%. Now, same topology, but the IT load is varying between 50% during the day and less than 30% during some hours at night. On the right side, we have the UPS efficiencies for the 50% and 20% and 25% load, with a difference of up to 2% when the load is under low conditions. The variation of the load over a year will represent a difference in the efficiency of 1.6% for ABB modular UPS, increasing the energy savings from 35% to 37%. It means that if the UPS is able to manage dynamically the energy consumption over the year, the energy waste is reduced. Better monitoring allows a data center operator to manage the power consumptions and operations. For example, local UPS interfaces allow them to check inputs, outputs, battery voltage and currents, power consumptions, temperature measure for critical components, events alarm as well UPS status and primary components status. Those data and analytics can be integrated into the building management systems for remote monitoring. The connectivity is accomplished via SNMP or Modbus TCP/IP. A good monitoring strategy creates a predictive insight, not only flags a component's replacement need, but also increase availability while reducing energy consumption. Talking about easy component replacements and the eliminations of human errors during maintenance is a topic to reduce the total cost of ownership, and therefore ABB has placed greater emphasis on these factors. For example, the UPS module can be easily removed with the help of a pallet and then sliding out on their integrated wells. In the workshop, the UPS module can be maintained having 30-60% degree access in a safe zone. Then the UPS can be slid in without affecting the critical load, as the power modules are online swappable. It means that by introducing, the active modules that we have in the system are still in doppel conversion mode, and by doing the maintenance in one module, we don't need to transfer the complete and overall system to the bypass path. We recommend regular checks and a good level of spare parts availability to keep healthy your system and support your data center operations. Thank you for your attention.
Thank you, Christiana and Diana. So that concludes the presentation portion of our webinar, and Christiana and Diana will now answer a few of the questions that we've received during our session. If you'd like to ask a question, you can still enter it into the Q&A section. We will answer as many as we have time for today. The first question I'll start out with asking Christiana is, if SF6 is a greenhouse gas, why is it still used in switchgear?
Because of its unique properties, electrical properties, it has been used in switchgear for a long time. In high voltage switchgear, for the higher ratings, there is no alternative to it. During the last years, there have been the search for alternatives, at least in medium voltage, and Air Plus is one of them. However, in the all-day life, the SF6 will not be released into the atmosphere, so the contribution of SF6 to the global warming and climate change is very low. For example, a 12-panel switchboard is lower than a regular family car emits during a year on CO2. So we have a leakage rate of less than 0.1% per year. It's only a low amount of SF6 used in the medium voltage switchgears, between 3 and 5 kJ per panel. And also we have a very low pressure of 1.3 bar absolute or 0.3 bar overpressure, which means there is a low stress on the gaskets. So they are tight for life.
Thank you. I have a follow-up to that. So is SF6 a health hazard?
No, it is not. SF6 in its pure form is non-toxic. If you go to the internet, you're probably going to find a couple of funny videos, because if you breathe in SF6, it makes your voice go very low and you can talk like this later. What is a health hazard is, in case of an internal arc, the SF6 will decompose and some of those byproducts are toxic. However, even if you have an internal arc inside an air-insulated switchgear, due to epoxy, copper, metal, and all the other materials burning, there will also be toxic gases around.
Okay, thank you, Christiana. The next question I'll ask is for Diana. I know you were explaining some of the UPS extra modes. So this question is, if the extra VFI mode is activated, what happens with the modules that are in standby?
Well, when the model is in standby, it turns the inverter off. So, and is disconnected from the main bus bars. So if the load is increases, then the module is transferred again to double conversion mode, putting the inverter on, and all this is happening in the range of less than 2 milliseconds.
Okay, great. Another question I have for you, Diana. For the UPS, are the power modules online swappable?
Yes, if there is a need to maintain a UPS module, then it can be removed without transfer the other modules into the bypass mode. Then the load is always protected in double conversion mode by the remaining modules. This is what we call online swappability.
Okay, great. Thank you. I'll go back to a question for Christiana. So, a question came in asking, if one device goes down, do you lose the interconnections between devices?
So I assume this question goes towards the relays in digital switchgear and how they are connected with IEC 61850 communication and Goose. This depends on how you build up your infrastructure. If you do a single daisy chain, you may get in trouble, but if you do a high availability seamless ring, where you need no separate switches, you can just use the internal switches of the relays. And you basically do a daisy chain, but then connect the first and the last relay as well. then you will not lose all devices, only the one that's lost, because the other ones can still communicate in the other direction. Or you use separate switches, network switches, and then you can build up a parallel redundancy protocol ring.
Okay, thank you, Christiana. I'll alternate and go back to Diana for another question that came in asking, can you add modules to Megaflex on field? And if so, how many modules?
So indeed, we can add. This is because we have the online capability. So when we insert the module inside the system will do an intelligent self-configuration, make the auto-calibration, and when they are ready, the system going into the load. So the answer is yes.
Okay, thank you, Diana. I'll go back to Christiana and ask about the toxic byproducts that are created during an internal arc in AirPlus. Could you talk more about that situation?
So as just mentioned, in any switchgear, regardless whether it's GIS or AIS, in case of an internal arc, due to burning materials, there will be toxic gases. Also, the air plus will decompose during an internal arc, but the byproducts are in toxicity somewhere in between an SS6 switchgear and an air insulated one.
Thank you. Another question came in for Diana asking if a module between other two modules is in failure on the DPA, is it possible to get off to maintenance by keeping other modules active and running load?
Yes, it is. Yes, it is. The other modules, if they are working in online double conversion, they will be continue. The failure module is going to be switched off and isolated as well automatically, and then it can be removed for maintenance.
Okay, thank you. I think we'll have time for one more question for each of you. So I'll go back to Christiana and ask, do you know if there's a data sheet available for digital switchgear? And also if ABB would be able to provide an AirPlus solution worldwide?
Yes, so that X0.2 digital is available to the ratings up to 36 kV, 2500 amps, 31.5 kA. And ZX2 digital is available up to 36 kV, 2500 amps, 40 kA, and available in single and double busbar. There are brochures available on our webpage, but we can also share data sheets for those products. AirPlus in principle is available in ZX2 design up to 36 kV, 2000 amps, 31.5 kA. It could be offered globally for projects. We have to check some requirements project by project. And as of now, the design is only tested according to the IEC standard, not yet according to the ANSI standards. If a customer accepts this, we should definitely talk.
Okay, thank you, Christiana. The last question I have here for Diana is, could you talk more about the maintenance plan for the systems that you've mentioned?
Definitely. I mean, the maintenance plan that we have and what we recommend is we normally recommend to perform a check every year and replace the consumables like fans, AC filter, and DC filter every 6 years to have to maximize the the design life of the system.
Thank you, Diana. I'd like to thank Christiana once again. We're coming up at the end of this webinar. And as a reminder, you will all receive an email later this week to access the recording of this webinar as well as the presentation materials. When you exit the session, you'll be prompted to fill out a survey, and we would appreciate any feedback that you have on today's event. Thank you all for joining, and we hope to see you in a couple of weeks for our microgrids for data center webinar.